Hi students, this is Kathy Biker for my college algebra class, and this is a lecture on rate times distance problems. And I want to tell you that when you finish this video, if you would please go to YouTube and watch The Real Meaning of MPH. It's a video about a husband and wife in a car, and he's trying to explain to her a rate times distance problem. It's rather humorous, but I would like for you to watch it to show you why it's important for you to know how to do rate times distance. I would certainly not want to see one of my students on this video. So let's start off with the basic formula. Rate times time will tell us the number of miles that we travel. So the first problem on your notes is the car is traveling at 38 miles per hour. That's our rate. And it's traveling for 5 hours. So if I travel at 5 hours, I end up with multiplying this together, I get 190, which would be 190 miles, which would be my distance. The second one said a woman rode her bike for 3 hours and she went 20 kilometers. So in this one, we don't know the rate. We want to find out what her rate was. So we multiply by 3 hours and we get 20 kilometers. So to find the rate, we're going to divide both sides by 3. And my rate is equal to 6 2/3 kilometers per hour. Notice it talked about kilometers, so we have to do kilometers per hour. Our time is always in hours. The last one is I walked a half a mile at 6 miles per hour. So we have 6 miles per hour is my rate. And I don't know my time, but I do know it went half a mile. So I have to divide both sides by 6. And when I do, I find my time is equal to 0.5 divided by 6, which is 0.08 1/3 hours. Well, which is really hard to understand. So what you do is you change this by multiplying by 60. So if I take this 0.0833333 and multiply by 60, I end up with 5 minutes, which makes more sense to us. The time, this is in hours and this is in minutes. So you take 0.0833333, goes on forever, times 60, because 60 minutes in an hour, and you end up with 5 minutes. Okay, so we have 4 different types of rate times distance problems. First one talks about you leave the same point and one is trying to catch up with the other. If you remember these from high school, somebody leaves the house and then somebody comes chasing after them because they forgot something, and they finally catch up to each other at here. I want you to notice the rates are not the same, the times are not the same because one left after the other, but what we do have the same is the distance. Okay, that's the first example. Number 2, it says they leave the same point and they stop, and how far apart are they? So here they are in the beginning and they both start at the same time and they go, and then at some point we say stop. So they both started and stopped when I said stop, so the time is the same. Here the distances were equal, here the time is equal. And number 3 is another type of rate times distance problem where you leave the same point, you go opposite directions, and one will go further than another, but at some point you leave from here, you start at the same time, you stop at the same time, but one's going faster than the other, so they're going to cover more territory. And when you get to the end, it wants to know how far apart are they. So you'd have to add their distances. But what we do notice here is the distance won't be equal and the rate won't be equal, but their times are equal. They started and stopped at the same time. And the fourth example is I leave in opposite points and we go toward each other. So like this. And this one's traveling faster and they meet up about right here. Well, they start at the same time and they end at the same time because they run into each other. But notice their distances are not because their rates are different. So the time again is equal. So those are the different types of problems we could encounter. All right, so if you go now to the next part B, I'm going to erase my screen here. Give me a moment here. Okay, so now if we go to part B, it says there are two cars, and if you notice, we've got our rate times distance box. Oh, it's so hard to draw in here. Okay, so I have, whoops. Okay, here we have our rate, times, and distance. And we have car A and car B. And it says they both drive for 2.5 hours. So we know this is 2.5, and we know this is 2.5. And now it says what's their rate. This one goes 60 miles an hour, and this goes 45 miles an hour. And so now we can figure their distance because rate times time equals distance. So if I take 60 times 2.5, I get 150. And if I take 45 times 2.5, I get 112.5. And the question is, how much further did one go than the other? Well, you subtract these two and you get 37.5. So that is the number of miles difference in those two vehicles. Okay, the next one is about traveling from Austin to San Marcos. And let me set up my box here. Okay. And it says a car leaves San Marcos going traveling north. So that means it's going to Austin. So to Austin. And the other one is leaving Austin going to San Marcos. Obviously they're on 35. And so the one that leaves San Marcos and goes to Austin goes 55 miles an hour. And it says at the same time a car leaves Austin and comes to San Marcos at 50 miles an hour. And so they're both leaving and they're going to run into each other. They start at the same time, they meet at the same time, so their times are equal. So the times are equal. So 55 times x is my distance, and rate times time equals distance, so 50 times x equals that. Okay, so now it says, how long will it take before they meet? Because the cities are 40 miles apart. So if I have one leaving San Marcos and then this leaving Austin and they meet here, well, this distance plus this distance has to be 40. So 55x plus 50x has to equal 40. So that's 105x equals 40. Divide both sides by 105. And when I do that, I get x equals 8 over 21. That is my time, 8 over 21 hours. So if I want to find out how many minutes that is, I can multiply this by 60 over 1. This is 8 over 21. And this cancels. 3 goes into 21 7 times, and 3 goes in here 20. 20 times 8 is 160 over 7. And if I divide that out, I get about 22.87 minutes. So that would be how long it would take before they would kind of run into each other. And I think that was the question, was how long will it take before they meet? So that would be my answer, minutes. My answer would be correct to say 8 over 21 hours. It just wouldn't have much meaning. And the next one, I'm going to erase the board here again because this one takes a little longer. Okay. This is the one about the princess. And so let's see if I can find my pen here. Here we go. Okay, so a boat named the Princess travels 511 miles before the prince even leaves the dock. The Princess travels at 73 miles per hour in its journey to Cancun. And what speed does the prince have to travel so that they end up in Cancun? Isn't that a great problem, seeing that that's where I'm going? Which is 657 miles away at the same time as the princess. Make my box. All right, and here's rate, times, and distance. And we've got the princess who's up early and going, and the prince is sleeping in. Okay, so the princess travels at 73 miles per hour. And we don't know how fast the prince goes because we got to figure out how fast does he have to go to catch up. We do know that they are all both going to Cancun, which is 657 miles away. Well, we do know now if we have 4 of the 6 boxes, we can figure the time. We could figure that the time of the princess is 657 miles divided by 73 miles per hour. And the prince is 657 divided by x. But we need a relationship between them. And what we know is that the prince left later. In fact, it was at 511 miles. Okay, here's the princess, and at 511 miles, the prince gets up and leaves and has to travel really fast to catch up with the princess. So I want to know, how long was this? At 511 miles, how much time was that before the prince finally got up? Well, rate times time equals distance. Well, we know the princess's rate was 73 times some time has to equal 511. Well, if you divide both sides by 73, you're going to find that your time is 7 hours. So it was 7 hours before the prince got up. So the time of the princess is 7 hours more than the time of the prince. So we have 657 divided by 73. Take away the 7 hours. And that's got to equal the prince's time, which is 657 over x. Well, this is 9. 9 minus 7 is equal to 657 over x, which is 2 over 1 equals 657 over x. Cross multiply. 2x equals 657. Divide by 2. And I find out that the prince has to travel at 328.5 miles per hour to catch up. I don't think he's going to make it to Cancun at the same time. Glad I'm not going on that boat. Okay, let me click and erase this. I thank you for being patient with my terrible writing with this thing. I'm not as coordinated with it as I probably should be. Okay, so the next problem is talking about a current, and we have to make our box, and we have a boat that goes up the river and against the current, and then it comes down the river with the current. And so we have to take that consideration when we do our rates. Okay, so we go upriver and downriver. Okay, so it says here the boat travels upstream a distance of 24 miles, whose current is running at 3 miles an hour. I don't know how fast the boat is going, but I do know that upstream I have to take away the current of 3 miles per hour. The trip up and back takes 6 hours. All right, so I know that the difference in their time is 6 hours. If the